Good morning, everyone. I'm Parv Dahiya, and I'll be taking you through the journey of this event. And I hope all of you are safe and sound. I thank you all for joining us on this beautiful day. I cannot express how thrilled I am to have you all with us for this webinar. We at Amity University acknowledge that these are testing times for every citizen of the world, but we also know the importance of preparation and to excel in these challenging times and make sure that these times turn out in our favor. And this is the exact reason why Amity University Haryana has planned this webinar. I'm inspired to see Mr. Anand Venkitachalam sir, who have blessed us with his presence. And I'm assured that his words will prove to be motivating and inspiring for everyone present here. Mr. Anand Venkatachalam is a Vice President at Western Digital, Bangalore, leading the engineering team of STM. This team designs, characterizes, and tests cutting edge 3D non volatile NAND flash memories. Anand has more than 25 years of experience in semiconductor industry and has held management positions at Cirrus Logic, Texas Instruments, and SanDisk. Anand sir holds 18 patents and has received his master's degree in electronics from the Indian Institute of Technology, Bombay, and his executive MBA from the Indian Institute of Management, Bangalore. Anand sir is also a certified yoga trainer and strong advocate of mindfulness for one's wellness. He's also a volunteer for Art of Living. I would like to invite Mr. Anand to enlighten us with his words of wisdom.
Thank you. Good morning, all. I hope I'm audible.
Yes, sir.
Yeah. Yeah. So I would really like to, take this opportunity to really thank Mr. Ankur and Mr. Manoj for giving me this opportunity to come and share a few words with respect to the career journeys that I think I had and share with you also that I think it also adds a particular perspective to you. So I'll be, kind of focusing on two aspects of it. One, what I call it as the professional or the engineering aspect, and the other one from the personal or the, the management aspect of it. So with that, let us get started. I will keep my presentation for maybe about 30-35 minutes, and I would give the remaining time for question answers, and let's make it, interactive. Uh, so let's get started. So we could go to the next slide. Yeah, this is a stand. Sorry, the previous slide, please. Yeah, I have to show the slide being an executive of the company just to make sure that these views are my own views. And in short, what it tells is based on this information, I think you should not go and buy or sell the Western Digital stock or the company where I work for. So that's a brief disclaimer statement, which all of us have to show that. Next slide, please. So before I, get started with my talk, I want to give a quick overview of the company that I represent, Western Digital. I think we are a very, sorry, there's a change. Went into the, yeah, thank you. Yeah, so I think so we are a leading data infrastructure company. We have a huge portfolio for all the storage things that are there. We have primarily two major technologies. One is the magnetic technology or the hard drive as we know of, and the other one is the solid state drive, which is based out of semiconductor chips, more specifically the flash memory as we call for. Combined in that space, we have a market share of close to about 50%. So we say that 50% of all the world's bits are stored in a Western Digital device. And the joke that we have is the best part of your picture or your video gets stored in the Western Digital device. So that's the joke that we have. So 50% of all the bits that are there in the world, 50% of them get stored in a Western Digital device. As you could see, we really work on the cutting edge of technologies, and we have close to about 14,000 active patents. We have 65,000 employees working for us all across the world, having major presence in all the continents. And we are a vertically integrated company. In other words, what it means is we design our own technology, we fabricate them, we assemble the product, and kind of sell the end product. My next slide, I will also walk you through the portfolio of some of the products that we have. And you will definitely recognize some of these brands, right? I think over a period of time, the company was built through acquisition. SanDisk is quite a popular brand. You all would have seen it. And Western Digital is also quite a popular brand when it comes to the hard drives. Next slide, please. Yeah, so this essentially shows how the 50% of the world's bits are stored in a WD device by showing you not only the breadth, but also the depth of the product lines that we have. Starting from the very basic components, which are sold as a chip level, to some of the retail devices that I'm sure many of you all have it and are using it, like the USB drives or the cards, or some of the portable devices like the passport, going all the way to some of the devices that get embedded into the latest iPhones or iPads or any of the laptops that you buy. And all the way, if you see the bottom row where we are talking about enterprise. So these are devices which host the data in the cloud, or these are the devices that your cloud service provider like Facebook or Google or Amazon uses to build their data centers so that all the bits are stored. So all the way from a simple component to having a complex setup that goes into the cloud infrastructure, Western Digital provides all that to enable you to save the data. Okay. Next slide, please. So you will see that in my talk, there are going to be a lot of analogies, and I'm going to use transportation as an analogy to kind of explain some of the concepts. So as I understand, many of you all you're going to be starting your journey from the career perspective. And one way for us to go from a distance A to distance B is the mode of communication that or the commute that we choose. One way is to walk, but faster than walking is really using the bicycles. And I use this example here because, Kritika, if you can just press the enter for the animation to come. I feel, for us to have a successful career journey, there are two P's that are very important, which are also like the two wheels of the bicycle that are there. One is the professional aspect of it, be it the technology and the subject matter expert. And the other thing also that would make a lot of impact or a difference really is about our personality, our leadership skills, or the the soft skills, many times which are also known as the things that are not very tangible. So I want to tell that if you want to really have a successful career, it's very important for us, like a bicycle, to balance and have both of them in the the right proportion. So I'm going to be sharing a little bit on the professional aspect or the technical aspects of in the domain that we operate and what can we see in terms of future. And then the last few slides, I will spend a little bit on the personal aspects of it, or the the soft skills or the leadership aspect of it. And then I will open it up for any questions that may be there. Really, my intent is also to learn through interaction. So I'm also looking forward for a very interactive session. So with that, I will move on to my next slide, which will a little bit talk on the professional aspects of it. So if you really see here, all around us, there is data, and the data is really the engine of the global economy. You can see people who control data like Google, or for that matter even Amazon, how much value proposition of business they have grown into. There are talks telling that if in future there is a world war that would be fought, it may not be because of water or oil, but it could just be because of data. And we see some of those fights already happening between US or Europe or some of the things, which is essentially telling how critical data is becoming for us. And when we talk about data, there are different aspects of it. There is the aspect of the overall volume, there is the aspect of velocity, and combining those volume and velocity, we could create value for the data. So what I mean by that, I will elaborate it a little bit more in my next slide. So if you really see the kind of scale, we are now operating in what we call it as a zettabyte age, or zettabyte is 1 followed by 21 zeros, right? And essentially what we are telling is from somewhere close to having close to 32 zettabytes of data in 2018, it would going to be easily 100 plus zettabytes by 2023. And predominantly, lot of these data of this volume will be possible to be generated because it's not only going to be humans that are going to be generating data, but it's also going to be machines. What I mean by machine is because of all the IoT, the sensor technologies, the self-driven car. So all those are depending on so much of intelligence and automation that the machine itself will contribute to greater than 90% of the data. So we have a huge opportunity in terms of the scale of data, and you can really see that it's growing really at an exponential rate. Next slide, please. So when we also talk about data, there are two aspects to it. One aspect, we call it as the big data, or which essentially means the scale. So here we are talking about problems like a genome problem or a DNA matching, where there is a huge volume of data that has to be analyzed. So the problem there is really about scale, or even some scientific exploration, like trying to study or understand the black holes kind of a thing, where Western Digital has partnered with some of the universities, where you really need a very, very large amount of data to be stored and then analyzed for us to make sense of it. If you could press the animation, please. But at the other extreme, we also have something that are really known as the fast data, where you have to make real-time decisions. Like for instance, an self-driven car is an example of a fast data, where you're going to be getting data at a pretty fast rate, but you also have to make a decisions very quickly. You can't say, hey, my sensor is producing these images, I have 1 hour to analyze it and then throw it out. No, by the time an accident would happen. So, or let's say a surveillance, where your face is your identity and it has to be analyzed, and a door or other things has to be opened. So those are examples where the data has to be acted upon or computed upon in a very, very fast manner. So that is what distinguishes the two spectrum of data. One is the scale and the other one is performance. And if you could click on the animation, the next slide, and that's where it's a big mix of data and algorithms that are all put together, and it needs very, very different set of architectures. It would really need different set of the compute infrastructure to be there. So here again, coming back to the transport analogy, if you just take the most common transport, maybe we can say it is the car. In our hardware terminology, we could tell as if it is a standard motherboard design, right? Which has a standard a normal general purpose CPU, and it has a storage. But with that kind of a common architecture, it is not going to be able to transport the data all across. Or in other words, imagine a world where the only mode of transport was cars. How difficult it would be. If you could go to the next slide. So if we look at it from the transport analogy, we have a whole different set of vehicles that we have, and we have a whole different set of engines depending on what is the intended use, right? So like we could have a cargo train, or we could have a cargo ship, that would carry huge amount of loads but travel at a relatively slow speed. That is an example for us like a big data. Or at the other extreme of it would be like a jet fighter or a racing car, where I think it has to carry very minimal load, but I think the speed is of essence. So in other words, what we are telling is, like, looking at this analogy of transport, when it also comes to the data, we are going to be needing very, very different kind of engines and configuration for us to be able to process all the different, types of data. If you look at it from what it means overall, or what we typically just call it as the cloud, essentially has three major components, right? One is the core or the cloud, which is typically a big data kind of a thing, where it will have a huge capacity. If you look at an Amazon, AWS or something like that, it will have a huge capacity. But for some of the real-time applications, also you need things to have a very quick response. So you're also going to need to have what are known as endpoint architectures. And for the data to move seamlessly between the two, you need what are known as the edge devices. Or in other words, if I have to look at the overall data architecture or the data storage aspect of it, it is stored at three different places, or there are three different places in the hierarchy or the architecture. One is the endpoint, which would even be your handheld device. The other would be the edge, so that you don't have latency challenges. And the third, really is like the core, where it stores a vast volume, or the bulk of the data. And in other words, what we are telling is, at the core or the cloud, you need something, an architecture like a cargo ship or something like that. At the endpoints, you really need things that are extremely fast, like a racer car, and somewhere in between in the edge, depending on the applications that you have. So we also need different storage devices with different capabilities. Not only that, but also different compute infrastructure at each of these different levels. So this is at a very top level. If you go to the next level, or from the architecture perspective, this is what it would mean, that a customization in terms of compute, interconnect, memory, and storage will be needed, depending on the end application that we have, as to whether the application is a big data, or really the application is like a fast data. If just I have to look at it from the storage or the memory analogy, for big data, you need a lot of those hard drive kind of devices, which can store in a lot of data, but they are very slow, right? Their access times are in the order of milliseconds. While on the other spectrum of that, you have SRAMs, which are very, very expensive, but they can really, kind of move data in, maybe in a few nanoseconds. So I think, so that is the spectrum of the velocity difference that we are talking about, from nanoseconds to milliseconds in terms of storage architecture, which kind of puts very different demands on the memory. So memory is not only a simple device that can only store data, but when we also look at memory, there are multiple different aspects on it in which we'll have to, optimize it. So if you could go to the next slide. So yeah, so this is what I was telling, that depending on the end application, memory is not just not a place where you store things, but depending on the attributes that you have in terms of latency, throughput, power, density, cost, retention, or endurance, many different types of memory has to be evolved. Or even for the flash memory that we have to fine tune some of these parameters, depending on the the end application that is there, depending on whether it is a fast data kind of an application that we have, or really it is like a big data kind of an application that is there. So these are the different challenges that we have, which also motivates us to build a broad portfolio of products, so that they could address the needs depending on the end application that is there. So those end applications are denoted on the right hand side by maybe the blue curve or the red curve or the yellow curve, which are different points with respect to the key attributes of it, which is, latencies or throughput or power. right? I think, and then I just bring this to the last point of my slide on the professional things, and then maybe I will pause here for a little. So as you would have seen over the last 10 to 15 years, the cost of, maybe you guys have been using the USB drives or even the cards, you would see there are two things that are happening. One, the cost per gigabit is reducing quite significantly, and B, the capacity is increasing quite significantly. Like for instance, I have been in the company for 14 years. When I started over here, even if you kind of had like a 32 GB kind of a USB drive, it was supposed to be state of art. Currently, from our India Design Center, the kind of products that we have designed is, you all know the micro SD form factor, right? The card that goes into your phone. Our highest capacity that is available, which we are very proud to say that which was designed by our India team, is 1 terabyte of data can be packed into that kind of a small device, which is nothing more than a fingernail uh, big. And when I was way back in college, if you had 1 terabyte, they would say that you are working on some super computing application, right? So that is the scale at which the density is increasing in terms of how many bits we can pack. And one of the ways that is possible is we make that possible by scaling in all the three directions. We call it as X, Y, Z, and logical scaling. When we say X, what we mean is the amount of size that a transistor is taken to fabricate, that is minimized. Let's say from 20 nanometer, you make it down to 15 nanometer. So that is the lateral scaling. The other way, the other option in which how we can increase the number of bits is by what I'm showing over here, which is known as the vertical scaling by our 3D NAND technology. The latest that we have announced in the market and which is publicly known is our BiCS5 technology, which has 112 layers. So imagine it as if you have a small house to a skyscraper which has 112 floors. Definitely more people can be fitted in the skyscraper, right? So like that, by building a 112 layer storied chip technology, we are able to really integrate very high amount of data into it. And the third aspect that we have is what we call it as the logical scaling. We all will be very familiar that at the end of the day, the basic building block of the semiconductor technology is a transistor, which can also be taken as an analogy as a switch, where depending on whether the switch is open or closed, you can either store a 0 or 1, in which case we can store 1 bit of information. But using our latest technology, what we call it as the QLC technology, we are able to pack 16 distinctive states into one transistor. Or in other words, what it means is that we can store 4 bits of information just in a single kind of a transistor. So that's the exciting part of the work and the technology that we have. So we have enabled this growth or this huge appetite for data by enabling scaling in 3 levels, right? Linear scaling, reduce the X footprint, as I told, from 20 nanometers to 15 nanometers to 10 nanometers. The second is the vertical scaling, which I'm explaining in this presentation, where we started from 24 layers, we have gone up to 112. Obviously, we are working on 2 generations ahead, but just because of the confidential nature, we can't tell you the details. And the third aspect of it is logical scaling, where instead of you storing 1 bit of information in a single piece of transistor, we can store up to 4 bits of information in a single transistor. So that brings to my last slide on the professional angle, and then maybe I'll pause here. So typically when people talk about complexity in chip design, like, we talk about houses, right? Whether it is a 1-bedroom house, 2-bedroom house, 4-bedroom house, the complexity of a chip is known by the devices or the transistors that are there. Typically people have a notion that in a CPU or a DRAM kind of memory, these are the most complex devices because they have somewhere between 10 to 20 billion semiconductor transistors fabricated on a single die, right? just note it. It's like almost like 3 times the human population packed onto a small piece of silicon. The world's population is close to about whatever 8 billion or so, and this is packing close to 20 billion of them in a single this thing. But in some of our, if you can click the animation, our latest BIX5 technology, we have close to 340 billion transistors that are integrated into a single piece of device. So that is the kind of the complexity that we are talking about. That is the kind of scale that we are talking about, which really enables us to pack such a large piece of data into such small silicon pieces. And that's where in a product form factor which is as big as your thumbnail, we are seeing that we can pack close to 1 terabit of data. So I will pause here this was a quick overview on the kind of exciting opportunities that are coming in the storage front because of the big data, the fast data, the AI and ML coming in, and how Western Digital is really contributing to it by creating the components and the product portfolio. So what I'll do is, I think is, Ankurji, if it is okay, can I pause here and see if there are any questions that I could take, and then I could a little bit move to the second part of my presentation, where I'll.
Anandji, I think we can continue with the session, and we can have good time slot at the end of the presentation, so that people can ask the question accordingly over there.
Sure, no problem. So then,
Yeah.
let's continue. So I think this is a symbol of infinity, right? And it has 2 arrows. So the way I see it is really the human potential is infinite. And if you see the symbol of infinity also, there is 1 arrow that goes inside, and then there's 1 arrow that goes outside. So my view of leadership essentially is that we have to really invest quite a lot in ourselves in terms of cultivating good habits, having a good understanding of ourselves as a person. And that investment, when you invest it quite significantly, it can then manifest outside as good leadership skills, which you can leverage to a lot of others. I'm sure many of you all, or maybe all of you all, right, would have definitely taken an aeroplane flight. So, when you have the oxygen mask, the way the air hostess tell us, we need to first put the mask on ourselves before we can kind of, put it onto others or save others. So similarly, what I kind of feel is leadership is an internal journey where we need to really build a lot of those internal attributes, and then only we will be able to radiate or influence kind of on others. The reason why I talk about this is in today's world and in today's complexity, it is really going to need lot of hard work apart from smart work, right? It's not like, hey, if you're very smart, you can avoid hard work. My experience is, hey, it is going to need both. And when it comes to hard work, I see myself having the challenge, plus to a lot of other people having the biggest challenges, a challenge in terms of work-life balance, or how, to me, what work-life balance means is, how do I energize myself? To give you an example, let's say you are not having a good day, you heard some bad news or something like that, and your energy is low. How much work you do that day, if you compare it to another day where you are very happy, you got some good news, and how long you're able to do, you would see that there is a almost like an exponential relation to the two, right? On a bad day, maybe you may get tired even by just doing a 1 hour of work. But if you're really passionate, if you're really excited, you could also end up really working really long hours. So then the key question there then to ask is, how do we keep ourselves energized? Because how much we are able to work hard or how much we will be able to contribute is really going to depend on how much energy that we can generate. And for that, if we could go to the next slide, that's my last analogy from a transportation. and it's our Indian vehicle, which is known as the auto rickshaw. I feel like auto rickshaw has three wheels. I think there are three major aspects of our personality that are there that A, we need to be aware of, and B, we need to do certain things at least on a weekly or preferably on a daily basis to kind of invest on it and to grow it. So the first piece I call it is the first wheel, I will call it as the body. So if you can press the animation, right? So if you are not physically fit, if you are not, our body does not sustain, then there is going to be very limited things that we could do. And so the one way to keep ourselves very energized at the body level is to do some exercise, be whatever it is, be if you're a gym going guy, if you're a runner, if you're a yoga practitioner, do something at least for 30 minutes a day to kind of have it done. Is body alone sufficient? There is another very important component that has to be there along with the body, and that is the breath. If you don't have breath, you're called a dead body and nobody cares for it, right? And breathing is also a very integral aspect of life, that we will do it from the beginning till the end of our life, but it is also the most ignored part of it. And personally, I feel we should invest some time to understand on the breath, and also understand how it relates to our body and how it relates to our feelings. That particular thing can also be very, very helpful for us in terms of managing ourselves, and by that process also managing the others. And that is what I would call, you could learn it from anywhere, but some little practice of breathing exercise, or as we call it as pranayam, is very important. And when you have a body and when you're breathing, there is always this thoughts that keep coming in the mind, right? And there is always a traffic jam that is there in the mind through the thoughts that come. So if you could press the animation. So the third wheel, which I call it, is the mind. And pretty much, I'm sure maybe the same you will also experience in Delhi, but in Bangalore, one of the biggest challenges we have is traffic, right? Like for instance, if there was the pre-COVID days when I had to go from my house to airport, which is only about 30-35 kilometers, it almost takes 1.5 hours. And why it takes that long is because of the vehicular traffic that is there on the road. And now, if you see during this COVID time, when the traffic is less, the amount of time that is needed to travel it is way smaller, right? It could even be like 45 minutes or so. So similarly, I feel in our mind also there is always a constant traffic. If there is too many thoughts, there are too many worries, the level of progress that we can make is very restricted. But if we can really focus in terms of one activity that we do, that really makes our mind like a highway, and we can achieve a great amount of activity in a shorter period of time. And one of the things that I really have been practicing and that has benefited me immensely has been a little bit of a practice of meditation or self-reflection, you could call it whatever you call, to kind of calm and clear the traffic of the mind. So I would say my closing thoughts with this slide is, please invest in yourself, because only if you have a healthy body, a healthy mind, rest of the professional aspects of it we would do. And in my humble opinion, I think these are the three basic components. I'm sure there would be others who are advanced and they can even tell there are multiple more layers on top of it. I'm not debating that, but these are the three basic fundamental layers that we have. And at least we need to do some investment on it, at least on a preferably on a daily, else at least on a weekly basis, to keep ourselves energized and focused. Right. So I think that's pretty much what I had in terms of the prepared material. So thanks a lot for giving me this opportunity. And I will be very glad to answer if there are any questions, comments, anything based on, what you heard from me, or if there was a different aspect that you would like to, hear.
Thank you, Mr. Anand, for the enriching session, and I would like to invite Perv to take on the questions received so far, and then probably we will conclude with the concluding remarks of Mr. Manoj and my colleague Mr. Chetan as well. Perv, over to
Sure.
you.
Thank you, sir. Anand, sir, first I have a few questions of myself. So, sir, since Western Digital is like, as you said, one of the leading organizations in memory and data storage. So, is there any possibility of Western Digital going forward and developing its own cloud in the future? As in, like, instead of supplying storage to Amazon and Google, creating their own cloud and be a competitor in that field as well?
Yeah, so I think we also did provide that in the past, but that's also one of the aspects of it that we are looking at to see how do we want to grow up in the value chain. But at the same time, we also have to be sensitive to make sure that we also support our customers, right, and don't end up becoming a competitor to a customer itself. So it's a fine balance that is there. So in today's world, it's very difficult to do things single-handedly, right? So it's always partnerships that are very critical. So with some of those large-scale, apart from retail, like if you go to an airport, you would see USB drives being sold on retail. But we also value quite a lot in terms of what you would call it as a B2B business models or the OEM business models. So with a lot of some of those big houses, we have a direct partnership to also enable them, and in that process also we grow. So yeah, so those are the options that we have, and it's a sensitive balance that we have to play into.
All right, sir.
It's a good question. Thank you.
Thank you, sir. So one more. Uh, is there already an existing technology or a technology being developed where artificial intelligence helps us organize how data is stored in our memory? Like, for
So
example, if I'm for example, if some data is marked critical or or through machine learning, the hard disk or the passport, it learns that this data has been very critical or has been accessed more often. So it is kept on like a more priority basis when it comes to backing up and stuff. So is there any such technology being developed or already existing in the market?
yeah, so I think there are two specific aspects that you're asking. So I'll split that into two different questions. So one, what you're telling is in terms of the uh, data usage itself, is there a smart way of storage architecture to store it? In other words, what you would see is there are certain data that we would use it on a daily basis. There would be certain data which we rarely use, right? I mean, you take a photo, you put it on Facebook, and maybe you don't access it for years, right? So that is what is known as how frequently a data is used. It's also called in terms of a color map. So whether it's a cold data means it will be accessed very, very rarely. Hot data means it is accessed very fast. And based on that kind of a thing, definitely there are architectures or solutions available where you would store the cold kind of data in a hard drive kind of a device, which is very cheap, but which is very slow, right? While you would use SRAM or our flash memory technology to store data that is needed very quickly, but clearly those are more expensive devices to store data as compared to a hard drive or even a magnetic tape. So that is the storage architecture. So that is one part of it. But you started your question also talking about something that is known as, is there an artificial intelligence that is there? So in the common terminology, or if you take up a basic course of computers, you would see that or in my slide also you saw, right, there are three major components, right? One is the processor, interconnect, and memory. In the classical architecture, processor is supposed to be having the brain, and the memory is just a dumb device, right? The processor tells, I want to read, I want to write, the memory just provides it. So that is the classical architecture that we have. But if you really see in terms of literature, we also have what now we call it as in compute or in memory computation. In other words, can there be an intelligence, or let me put it in a different way. Classical architecture, you have a processor which is surrounded by memories all through. Now what we're telling is, can you do the reverse way around? Can there be a memory and can it be surrounded by processing? So that data comes in, the processor processes it, and only the intelligent part of the data gets stored, and you kind of drop off those remaining things. So that is what is known as the in-memory computing, and with this kind of innovation that we are doing, that is very much possible. And if you really see some of the latest artificial intelligence and other kind of architectures, they are kind of moving away from the classical memory architecture, which in my transport analogy was more like our standard Maruti car kind of a thing, to what you're really asking is a fighter plane kind of a thing, where can the focus be on the memory and processing being around it. So those architectures are also there.
All right, sir. Thank you so much, sir. There are a few other questions from my mates. So Aman Janu wants to know about the current and future job opportunities in the field of data storage and this, like for example, in SanDisk and WD.
No, I think we have close to 3,000 people. We hire quite regularly, and in fact, campus hiring is one of our key aspects to it. Definitely, to Ankur sir or somebody, I can put them in touch with our HR team, who can then take it forward. So we do that, but essentially, from if you got the gist of what I'm talking, is we are talking the data growing from 32 zettabytes to 100 zettabyte, right? So this is going to be an era of storage, and it's going to be an era where instead of humans generating data, now machines will start generating data at a very fast rate. So data, according to me, the next 10 years at least, right, really will be stored by it. Like for instance, in 2000, if you had asked me, I was also part of Texas Instrument. That time, the mobile was the one that was driving the world. In today's this thing, it is really the storage that is going to drive. And just look at your own life, right? From we sending simple text messages. Nowadays, what do? We share videos, right? And just look at how much bytes are needed to send a text message to a video message. So it's not a very high-end trend. I'm telling you, look at the trend that we are creating, or how we are doing, or even look at this, right? The whole college and the seminar is virtual, is becoming possible because of, definitely some storage mechanism being utilized and compute mechanism. So I feel this overall area of storage has a very, very bright future. To also answer it in a little broader way, rather than just, because I'm not telling that, hey, the storage industry, only Western Digital is there and only Western Digital is the only job provider. But this whole market segment has a very huge opportunity.
All right, sir. So Yashwinder Bamil wants to know, how are 4 different states stored in a single transistor?
Yeah. So what, it's a little bit more technical aspects to it, and maybe you can also definitely, nowadays the guru for everybody is a Google. If you do a Google search also, you can find it. But in a very abstract level, I will tell you this thing, that the basic underlying principle of this is a CMOS transistor. But in this case, we use a very special transistor, which is known as a floating gate transistor. Normal CMOS transistor has only one gate. These CMOS transistors have 2 gates, and one gate is surrounded all through by oxide layer. And there is an external gate. And in that external gate, when you apply very high voltage, and electric field gets done. So the electrons tunnel through the oxide and go into this floating gate. And then there's some charge built on the floating gate. And that charge then changes the threshold voltage of the transistor. So by controlling the amount of charge that is there on the floating gate transistor, we can have 16 distinctive threshold voltage for the CMOS transistor. And by sensing which threshold voltage is there, we can store, 16 bits of information onto that, right? So you look at it like there are energy lobes, where there are 16 such lobes that are stored. And if you can store 16 distinctive states in a transistor, which is 2 to the power 4, which means that I can store 4 bits of information. So that is how it gets stored. a little difficult to answer only on this thing without a diagram, but
no, sir, that's like it was quite elaborative.
okay.
And sir, Ankit Dhamija wants to know what technical skill sets should be possessed by management professionals, that is someone coming from a BBA and a MBA background, to get a job opportunity in IT sector.
Yeah, so I think, definitely I would say some basic understanding of some of the IT principles would be needed. But I think, from more also from the management side of it is also to look at how do you understand the end-to-end business process, and how can you bring in efficiency to that process. That is also equally important. Like, for instance, to give you a feel for it, I said that we have close to about 65,000 employees that we have. So out of that, maybe our engineering strength is only close to about 10 to 15,000. The rest of them are all part of our operations, right? Because you need a factory where all these things get produced. So you have to apply management principles in terms of how do I, create a work chain? How can I do most of the things in parallelism? How can I bring down my fixed cost? How can I optimize my variable cost? So all those things are also equally important for a company like us, even though it is projected as a technical company. So I think those management principle essentially means technology defines how a thing can be done. Management needs to find out how to do it more efficiently by using the minimum number of steps. So that's where I feel both aspects of it are very important. So even if you look at it from a personal aspect, one thing is, hey, I have to do the job, and the other one is how quickly can I get the job done, right? That's where one is the smart aspect, and other one is the the hard aspect. And I think management comes in when once the hard part of a technology has been figured out, to figure it out how to make it more efficiently. So there is a huge tremendous scope, in my opinion, because there are always processes which technology will define, but which will need optimization.
All right, sir. Sir, Neeraj Sharma wants to know that since large volume of data are being processed and stored, so how will this affect our environment? Like, will there be larger CO2 emissions in the environment, or like what would be the impact of introduction of big data and like so much huge amount of data is moving from 32 to 102 zettabytes? So what would be the impact on the environment?
Yeah, so clearly, I think it would have an impact, right? If we just continue to just do the design based on density without giving any regard to power. But I think a modern day, that's also a technology constraint, is not only in terms of being able to store a data, but we also measure in terms of how much energy is needed to store that power and really to optimize that. And that is, if you saw that web chart kind of a thing, that's why power was one of the attributes that was there. So today, with so much of sensitivity around our around our environment, that is kind of becoming a very, very critical component, and that is also giving us a lot of opportunities. And that's where I think new research will also come, not only in terms of density, but also to kind of see what would be the newer materials that or techniques that can really do this at a very, very low energy level. I recently, only last week, I was seeing this experiment by Microsoft, right, where they're planning to have their data centers submerged deep inside the sea, so that they can, kind of optimize on the power needed for, cooling it. And so those kind of innovative techniques, for at the material level, or in terms of the basic devices, B in terms of the infrastructure itself, are becoming very relevant. And I think a lot of research is going there. So I would say, yes, if we just linearly went about it, it can be destructive to the environment. But there is focus, and that's why if you see a lot of products, like even when you go to buy an AC, right, you see whether it's a 3-star or a 5-star, right, from an energy perspective.
Yes.
So similarly, people also are not nowadays not just buying. Maybe at the retail side we don't see it, but at definitely the corporate side, people just don't buy it for the capacity, but they are also more interested in at what power can you provide those capacities. So there is awareness around it. That is a business constraints, and people are working around it to make sure that while we grow this, we grow it synergistically with respect to our environment and not destroy it. Sorry, a little long answer for a short question.
I know, sir. Sir Abhishek Gorai wants to know, what is big data discovery and how does it complement traditional business analytics?
Yeah, so I think there are multiple examples of it. I don't know. I will talk about one example from a banking perspective. If you see, just look at, maybe talk to your parents, see how for operations, how many times they have to go spend time at the branch and other things. Do you look at how you transact? How much hours you have to spend with in front of a branch? It has come down. The one aspect where it has made a big impact is also in terms of loan processing. I don't know whether you guys have read it, but you can also see it. Like HDFC has been one of the banks that has been at forefront of bringing this kind of a digital transformation or digitization. So they say that you have so much of customer history. So if you have a loan threshold, I think the threshold was 10 lakhs, it can change just on my information. So below 10 lakhs, you apply for a personal loan or stuff like that. It gets approved instantly because a big data or a machine learning algorithm is running behind, because it has connected everything. It has your credit card transaction. It has information extracted from so many sources, right? Maybe from your form 16 to figure out how much salary you're making, how many other loans you have, how much is your income tax you're paying. So it collects all this plethora of data, and based on that finds out your credit worthiness and instantaneously, approves a, kind of a loan for you. So this is one very simple, practical experience thing I'm telling, but just look into it. There are multiple areas where data is coming, and you look into any of the service companies, people use different words. People use words like automation, people use words like digitization. Essentially, all that means that I'm moving away from a human process, and more business processes are being managed by computer tools. So it is very prevalent. You may not know it, but if you do it with a
Yes,
little
sir.
awareness, ask the question, you will see that it is very broadly penetrated.
If I may, I myself
Please.
am from BTech Computer Science, so I've been studying a lot on machine learning and artificial intelligence lately. So I'd like to add to this that even the very basics of seeing an Amazon review on Amazon.com, those reviews are being read by machine learning, and compared to the big data they have, and are being marked as positive or negative. So that is the level at what big data has been, integrated into our lives.
Sure. And another example, Pav, is also, if you use Gmail, if you keep typing, depending on the words, you see that the ads start matching that, right? So you see
Yes,
how
sir.
much intelligence is coming into it, rather than, just throwing a random ad. Even those ads are getting targeted depending on with whom you're talking and what you're talking. So somebody is, analyzing all these things that are going on.
Yes, sir. So, sir, Mansi Bhardwaj has a very interesting question that in other countries, every person's genomic information is saved on chips, which helps them to diagnose and treat the disease within appropriate amount of time. So, why is such technology not being developed in India yet?
No, I think, we have it in terms of the infrastructure capability. It's a more a question of how to broadly deploy it at the cost points that we have, because India itself is always a very different market, right? You look at our telecom, if you see our data rates, they are they're the cheapest in the world, right? In
Yes.
US and all, maybe 5 to 6 times. So India also has its own unique challenges brought by people like us, because for us, cost efficiency is very high, right? So first we ask cost, then we ask for what are the features, isn't it? So because
Yes.
of that, we have to innovate it in such a way that the price points become very attractive. But I see, the government, because we also work with government, we work with startups. I think the government also has a lot of push towards digitization. I think the Honorable Prime Minister also announced the digital health cards. So I think it is moving in the direction, but just from where we are, maybe it will take us a little bit more time, but it will happen.
All right, so we come to a last question with this, asked by Neeti Chatterjee. She wants to know that from perspective of management, how can artificial intelligence, machine learning, and big data help us in managing knowledge in an effective manner in organizations?
Yeah, so the way I would look at it is most of the business decisions anyway nowadays are all driven by analytics, right? So if you really see any company, it has a lot of analytics, right? Looking at customer behavior, customer profiling. So I think that kind of a scale is being enabled because of big data. Otherwise, if only humans had to do it, maybe you may have needed 10 lakh people to reach out to that big customer base. So one of the ways the data is enabling us is by replacing multiple human beings by just a computer algorithm, and you just have to oversee it and then see whether it is adapting it in the right way and you're building the right intelligence to it. So I would say it is helping management in a big way in all aspects by the scale, right? If you really look at it today to 20 years back, what has been the difference is the scale, and that scale has been possible because of big data, because management was there then, management is there now, management will be there in the future also. What would define is the scale has increased quite significantly.
Yes. So the last question from my side, it is more of a personal,
Sure.
the personal side of life question. So since this lockdown happened, like before the lockdown, all of us, even the students and all the professionals, we are quite busy in our life, and maybe we never gave our mind the time to sit down and think like what all is going on up there. But since the lockdown happened, personally, I have had quite some instances where there was so much cluttering in my mind, like there was so much, like there was big data in my mind, and I cannot just process what to prioritize and what to look up to, and what is the data that I do not need, maybe the past. I do not need to encounter my past again and again. So like this thing is happening not to me, but a lot of people that I talk to on regular basis. So how do we basically prioritize or cleanse our mind uh, of the thoughts that are not much needed, and make space for the important part of our life?
Yeah. So I think you brought up a very good point. So I will tell you what you called it as big data is correct. But remember, even in the real world, many times the data is big because of noise. So what you described in your mind, I call it as the big noise, right?
Yes.
And that's where we talked about AI or the intelligent storing. It has to only store the relevant piece, and maybe 90% of the data is kind of useless. So that's what, from the architecture perspective, we are trying to optimize, right? And what you're telling is also very similar. How do I keep that essential part in my mind, and how can I drop the other one so that I'm free and I can do more things? I think there could be many ways. Personally, for me, it has been the practice of meditation that helps to just it can start in a very simple way, right? Just take 15 minutes out, 10 minutes out, just sit calm and just observe yourself. That kind of helps us to little bit bring a perspective of what is important, what is not. Otherwise, there's a chain of thought, just one going behind the other. We don't know where to pause. And even some of the breathing techniques help quite a lot. Because just remember, right, when you are very frustrated, very agitated, how is your breath? It is short and
Sure.
fast.
Sure. Yes.
When you are very, very happy, yeah, the breath is long and deep. So that itself is, we have not spent our attention to bring it to certain things, but there is a clear relationship between breathing and the feeling. Next time, try to breathe slowly when you are getting angry. You see what happens. You will see the anger goes away. So, so by breath also, we have a lot of indirect control that can be done. So that's where I'm telling those personal investments has to be done, because in my experience, what I've seen, Parv, is from a chowkidar to the Prime Minister of India, everybody is busy.
Yes.
But in terms of output, it is very different. So that is where it will depend on how much relevant data and relevant work are you going to do in those 24 hours versus how much time is going to be spent in irrelevant things, or the noise part of it that I called. And that's where that cleansing process is important. Personally, for me, what works is basically a little bit of an exercise followed by pranayam, followed by some meditation. As I told you, I'm a volunteer of Art of Living. They also do a lot of these online breath and meditation workshop. They teach a technique that is known as the sky technique or the Sudarshan Kriya. I have been a practitioner of that for the last 14 years, and I can say that it has made a tremendous impact personally to me. I don't know about others, but at least that's my secret.
Thank you so much, sir, for sharing your personal experience and all the professional knowledge that you shared upon us today. So with this, I'd like to hand over to Ankur Gupta, sir, for the further proceedings.
Thank you, Pab. Before I invite Chetan and Manoj, there is one last question from one of our senior faculty from management, Dr. Ajay Kumar Pandey. Want to know that there is always a gap and even conflict between database systems and real life situations. The IT systems must become adaptive to real life situations. Do you think in future the IT system would be organic enough to accommodate all real life situations, or the gap will remain in future also?
No, I think it is very true. I would give an analogy, between personal life also. Many times we know what is the right thing, but what we end up doing is always different, right? So similarly, that kind of a gap will also exist in the systems, and it will get addressed iteratively. Having said that, even those challenges we also face. We are also a data company. We also face, but that is the agility part, and that's where we will keep minimizing the gap. New gaps will come, but when you see it over a period of time, we would see that we would have evolved it. I don't think there would be a day that we would come, everything is perfect done. Then honestly, then we have nothing else to do, right? So, but I think that pressure will be there between what is needed and how the system evolves, and that will keep us all challenged. But those gaps are real. I want to acknowledge that.
Ankur, I believe we have already exceeded and taken more of Anand's time today.
Sure.
Yeah. So first of all, as the closing note, Anand, much thank you for for this interactive session and taking the time out to address our students. And I must say, though it was a very engrossing session, specifically in terms of the questions the students asking you, and it was very interactive. And you've also given them insights on the exciting opportunities in the field of data storage. And the best part I would take as a as a takeaway is for the students to engage themselves in fun activities and keep their mind stress free, because only then they would be able to generate the output. There is so much of pressure on these kids, so they need also some time out, and then they perhaps their brains can function better, and better thoughts can evolve out of it. So having said that, Anand would look forward for more opportunities to interact with you and would welcome you to our campus whenever you're towards this side. And looking forward for a good association in future. Thank you so very much, Anand. Chetan, would you like to add to it?
Thank you, Manoj.
Thank you to Anand. Thank you so very much, Anand, for your kind words, your time, your precious time, especially during the working hours. We understand in these online scenario, people are far more occupied because we ourselves are struggling very much a lot with regards to the time and all. So having also, as you have shown the auto, the auto, there are three kind of stuff which you have mentioned about 3 dimensions. So having said this, in today's scenario, students do not have dilemma. They have trilemma. One is with regards to the career, another is what exactly they are looking forward for, and third is money making. They all want money, the money making machine should come to them. So therefore, your words of meditation, thinking about yourself and coming, you have to listen to your own voice. This is what as you have mentioned about it. These things are really amazing, not only for the students, but rather for all of us. So thank you so very much.
Trust me, Chetak, it works, because even I do that, and it gives me a lot of relief, and I can do much better. Thanks again for endorsing my views, Anand.
No, and if I may just add, Chetan, I know that in the young generation, I think money is critical. I'm not telling money is not critical, but having been in this industry for 25 years, what I would tell is, that please chase the excellence and money will follow you. There is no football player who's the world's best and he's paid the least. Take sports, take anything, if you are the best actor, you will not find an example of a best actor, but he's the least paid, right? So I would say early stages of careers are like a rocket. You need a lot of energy in the booster stage. Please focus in terms of subject matter expertise, exposure, so that in the later part of your career you can leverage them. And if you are the top of any field that you choose, two aspects of it: you should be at the top of whatever you choose, you should have fun while going to the top, money will follow you. Please remember that. If you run behind money, I have seen people destroying careers because it can give you fantastic money for 2-3 years, and then all of a sudden, when the job changes or the company changes or the market changes, they don't know what to do. Almost looks like the example of, we have a lot of dogs in Bangalore. They come barking. When you bring a car, you would have an experience. They come running. Next time, do an experiment. You just stop the car, and then the poor dog does not know now what to do. It can neither bark nor does it know how to run away. So I say, please don't be like those dogs running behind money. Run behind excellence. The money will follow you. I know, to the young crowd, too much of prescriptive knowledge is not good, because I have a teenager at my own house. But still, given this platform, I would just like to share my life experience.
Aptly put. Ankur, last comments, please, so that we can close the session.
Yes. Once again, thank you, Mr. Anand, for your wonderful insight. Combining two important aspects of any life over here is like technology and management. So which again I also feel are two important pillars of any business. So and quite a lot interesting questions being asked from our students. Really wonderful to see that as well. And we look forward, Mr. Anand, to have leverage this association in different form in coming days. This is just the beginning of the relationship with your esteemed organization as well. So we look forward for certain different engagement activities with your organization in coming days, and we look forward to join hand in that industry academia domain for a longer run. Thanks again, once again, Mr. Anand, and a special thanks to Ms. Kritika also.
Yeah, I was about to say that.
A special thanks to Ms. Kritika for helping out Mr. Anand to seamlessly transmit this session to all the students, and we look forward for your support as well in coming days. And once again, thanks to my IT team as well for bearing a little delay in start of the session because of certain technical glitches. Once again, thanks all of my students, my faculty members who have joined this session. Thanks a lot. Have a good day ahead. Thank you.
Thank you, Anand, Kritika.
Thank you.
Thank you.
Have a good day.
Thank you.
Be safe, be healthy. Thank you. Bye.